course, and okay. Everything is okay. You can see everything.
Yes, I'm watching your presentation.
Okay, very good. So this is the fourth lesson, and we will first check, because I checked your homework. We will first discuss about your homework and a question that you had in the last lesson. Then we will go to the remaining topics from NumPy, and we will explain them through some examples, copies and views, reshape, ndim, arange. It's not arange, it's arange, and traversing over ndarrays, broadcasting. Then we will go to the function syntax, function arguments. We have 4 different ways of passing the arguments in Python. It's positional arguments, keyword arguments, default arguments, and variable length arguments. Then I will show you that Python does not support function overloading, although in many resources people are referring to overriding in Python as overloading, but it's not overloading. I will show you this is not overloading. And immutable parameters, functions, how they act in the functions, and anonymous functions, or we can also call them Lambda functions. Then I will give you some exercise, some homework to do it at home. The next topic that we will discuss about is classes, getter and setters, instance, and class variables. We cannot, I mean, I hope we can cover this topic in this lesson, because we only have 2 more lessons for in this semester. So it's, I think, what happened? Sorry, I have a call, so I have to wait for a moment, and then I will continue. This is a call from Adrienne.
No problem.
Sorry, I had a call from Adrian, so I had to reply that.
No problem. It's okay.
Now? Okay.
Yes.
Let me see. Let me just check something. Do you have also my video, or just a screen?
I'm watching the presentation in your Mac.
You don't have my face?
How? Excuse me?
I mean, let me stop sharing first, and then I think it's better. Oh, here. Sorry. Stop sharing. Now you can see my face, or my camera, I mean.
Yes, I'm watching your face.
Okay, thanks. So now if I share the screen, you should see the screen, because I just stopped the camera, and I was not sure if you can see everything. Okay, let's continue.
Okay.
So we only have 2 more lessons, so, and because of that, we have to cover the at least part of the topics in the classes in this lesson. And Because since we do not have many lessons left for us, and I think I cannot cover all the topics in NumPy library, and but if we find enough time in the last lesson, we will come back to this those topics as well. So first, this is the exercise, the homework that you did. I gave this solution in the second lesson to you, but I want to compare this one with your answer because I found something interesting in your exercise, and I thought maybe you know the answer now, but I thought it might be a problem for other people who are listening to this course. They are not attending to this in this course, but they are listening to. So the exercise was to create a tuple which includes 3 different items: a list of integer objects, a float object, a str object. And I asked you to update the elements of the list and check what happens to the tuple and the list objects by checking their IDs before and after the update. So here I created a list and a tuple, and the first element is a list, the second floating point, and the third is a string. You also created a similar list. This is your answer. I just copied that to one online interpreter. You first created a list object, and you use this reference to create another tuple. This is okay. So this is another way of doing what I did here. So I printed the ID of A and ID of the first element, which is a list here. And as you can see, this is their IDs. And then I one element to this list, and then print that one and showed the ID of A and ID of the first elements here. So as you can see, the ID of the tuple didn't get changed, and the ID of the list also didn't get changed. Even if we are saying that, although we are saying that the tuples are cannot be changed, but if they have a list as one of their items, we can change that list, and so in so doing, we can say that the tuple also has changed. But what you did, you also changed the list, but to this variable, not through this variable. So you use the variable, the reference that you had to this list to change that list, and also it will change the tuple. This is the line of code that I added to your piece of code to show you now after this change, your tuple also has been changed. You can see here, this is the tuple that you had. The first values of this tuple was this one, but now you change it to this. So this also has been changed in the tuple. But you didn't write this. You didn't change this. You tried to change GU tuple through this list again here. But the problem here is I told you to define a variable which is equal to define to create an object, you use just an item assignment. So by doing this, you're just creating another object. You're not changing this object, this tuple. You are creating another object. And if you check the ID of this one, the new, this one, the ID of this one, the ID is different from the first one. You can see the ID is, so you are not changing the same object. You are creating another tuple by this command in the line 8. So this is really important because this is not the case in other languages, but in Python, since when we are defining a variable, we create an object, and to do so, we only do the assignment. This is different from what we had in other languages. And it is the case for all the variables, either they are mutable or immutable. If you use assignment, you will create another object. And so what you in your email, you said that I noticed that the ID of this tuple and the third tuple here are the same. Actually, we discussed about this in the second or third lesson. So you may know that now, but just to be sure that everything is okay. The reason here is this is not a logical behavior. This is related to your interpreter. So if you run this piece of code using the other interpreters on the internet, you may get other value here, other ID here. Why? In this interpreter, the garbage collector in the interpreter thinks that there is not any identifier, any variable referring to this tuple, to the first tuple, the one that you just created here. So since there is no one is referring to this tuple, let's delete this one and use this location of memory for the third tuple that you are creating here. So they are not the same. They are two different objects. One of them is deleted using the garbage collector, and the other one is created using the interpreter and stored in the same location of memory, since the type of them are similar. So this is not the thing that you can handle. You are not doing that. This is based on the algorithm of the garbage collector, which is inside your interpreter. So if you see something like this, you should not think that these are the same object. These are two different objects. One of them is deleted, the other one is replaced, is stored in that location of memory. Did you get this, Gio?
Yes, now it is clear the reason why.
Okay, very good. You also had another question. I don't know why it doesn't show. Okay, it seems that there is a problem with my... Okay, very good. You also had another question in the last lesson, and we had one example here. This is the same example. I only add this line to the same example. We first created a data type, which is a data structure. We are familiar with data structure in NumPy. We discussed about them in the previous lesson. Then we created an empty NumPy array with the shape of 3. So every item of that has the data type like this data structure, because I defined d type equals dt. I printed a here. This is what we can see. And I printed here A0, the first element is this one. The type of A0, it gave me class numpy.void. And I said that if it is a scalar, yes, it is a scalar because it's an item from our NumPy array. Here, in that lesson, you asked me if this is the case for all the objects that we will see numpy.void. And I said that the reason that you see numpy.void here is because we are using type, which is a built-in function in Python, not in NumPy. And Python does not have access to d-type. So the only thing that Python can see from NumPy library is the wrappers, is the interfaces that exist between Python and NumPy. So with this one, we will see numpy.void, which is a base class for our data types. But if we want to see the exact data type of A0, we should use D type, which is an attribute of this array color, and this attribute is defined in NumPy. So as you can see, if I use D type, then I can see the exact data type that I defined here. This is just another way of calling float, as we discussed in the last lesson. So I want to, in the previous lesson, I asked you to check this one by yourself, but just to make sure that everything is clear, I also checked that one and showed you here. Okay, let's go to the other topics in NumPy. So in NumPy, we have the other topics that we have is copies and views. I'm explaining these topics to you using these examples. So first, I created a list here, and I want to see what will happen if I assign this variable to another variable. So this would be like, with this line, AR will refer to the same object. So this one is like assignment by reference. But we know that from the previous lessons, we can, instead of sending the assigning a reference to another variable using another variable, assigning the reference of one variable to another variable, we can copy the items of one variable to another variable. And how we could do that using these four different structures. So we said that we can do it with the slicing, we can do it with this advanced slicing, we can do it using list constructor, we can also do it with copy method of the list. And if we change one element of AR, this change will be propagated to AR as well, because AR is also referring to A, but these four variables will have the first items of the list. As you can see here, A is, after this change, A is 10, 2, 3, which was first 1, 2, 3. AR is again 10, 2, 3. But with these structure, with this syntax, all these variables are still referring to this one, because all of them are different objects. They are not the same object. If you check their IDs, you will see that they have different IDs from AR and A, but AR and A have the same ID. Let's do this one for NumPy arrays and what we will see by doing that. So I'm creating a NumPy array with the same values. If I do these three commands, if I run these three commands, this would be like referring to the same object. All the variables will refer to the same object. So this is similar to this. This is similar. This is not. This is I'm creating another array, NumPy array, and I use these arguments of the NumPy array to make it as reference. By default, copy is true. So by default, if you just write like this, np array A, it will copy the item of A and create another object, and D will refer to that object. But if you write copy false using this constructor, then AR2, this variable, will refer to A with the same ID. And if you change A, that change will also propagate that in AR2. And if you change I mean, if you change one of them, the change will be shown by both the variables. But unlike what we saw with the slicing in list, with the slicing in Numpy arrays, we will have a view of that variables. So the data is the same, the view might be different, but here the view is similar. In the next slide, we will talk about what is view. But you can, for this slide, you can consider it like referring to two variables which are referring to the same location of memory. So in this command for Numpy arrays is different from the same one in list. Here it leads to copy. Here it leads to a view of that variable. We can do these two, as we said here, to have a copy of our Numpy array, and also this one to have a copy of our Numpy array, like what we had in list. But this one, which we had also in list, will lead to a list, not a, which I printed here, which leads to a list. It will lead to a list, not a Numpy array. So Numpy has ndarray.view method, which is a new array object that looks at the same data of the original array. The change in the dimension of the new array does not change the dimension of the original one, but the change in their data will be shown in the other variable. Slicing an array will create a view of that, but slicing a list will create a copy of the list. And if you want to have a deep copy of your array or your list, you can use copy function. We saw the examples in this slides. But let's check in the array views and how they are really working. I'm here using a function Numpy array, which is arange. It is similar to range data structure that we had in Python, in built-in Python. I mean, in a standard Python, it will give me a range of items from 0 till 5. I can reshape it to an array of the shape of 3 by 2. And if I show A here, you will see that it has 3 rows and 2 columns. I can create a view of this array with this command, a.view. When I print B, okay, create a view of A and print B. This is print B. It is similar to A. And if I check their IDs, their ID is different. Even if their ID is different, their data is the same, but their shape can be different from each other. So changing the shape of A or B has no impact on the shape of the other one. So if first I'm changing the shape of A here, which was 3 by 2 to 2 by 3, and then I'm changing the shape of A again to 6. So even I can change the dimension. Now here, the dimension here was 2, but the dimension here is 1. So it's okay, we can be reshape. We have two ways. Either we can use reshape or we can use dot shape, the attribute, to change the shape of the Numpy array. But changing the items of A or B leads to the same change in the other one. So here A has the shape of 6, so it's like a vector, and I'm changing the first elements of that to -1. And for B, I'm changing. B still has the view, has a shape of 3 by 2. With 0 and 1, I'm referring to the first row and the second elements of that. So with this one, I'm changing this element by 10. So if I now print A, in A, I will see -1, 10, 2, and the rest. And also in B, I will see -1, 10, 2, and the rest. Because their data is the same, but their shape is different. So if I want to have access to this element, to the same data, in A, I should use A1 to change this one. But if I want to change this value using B, I should use B 0 and 1. So, but their data is the same, because if you remember from the last lessons, I said that Numpy arrays are stored next to each other, either row by row or column by column in the memory. So the shape is just another how you will look at that part of memory. The shape is not reflecting how they are stored in the memory. The shape is just how you will look at that location of memory. We said that with dot view, we can create another view of our array, but we can also do this with the slicing. So here I'm creating another array, and when I print this array, our array is 10 by 10. This is what you can see in your output. With this one, I'm creating a slice, and so since I'm referring to all of the items, it gives me the same. When I print that I can see the same. If I change A0 and 0 by -1, which means this one, then A and S, both of them will be changed. Here they have the same shape, but they could have different shape. But you should remember their ID is not the same. Let's check slicing for lists and arrays. In this one, I'm creating an ndarray. This one is indexing, it's not a slicing. You should differentiate between indexing and a slicing. So with indexing, I'm accessing the first elements here, and I'm copying that value to another object, and B is referring to that object. With this one, this is a slicing, but the results of the slicing is just the first element. When I change the first elements, so this will lead to a view of the first element. The shape would be the shape of this array. So now I'm changing the first elements of this array. And I'm changing that to 10. If I print A00, I will see 10. If I print B, I can see 1, because here indexing leads to copy. And with C, I'm creating another view, so it has the shape of this array 1 by 1, and not exactly the same because it has let's say something like this. In list, when we had a slicing, the result was a list, even if it only has one element. Here, the result would be a Numpy array, but not exact. The dimensions would be the same, but the shape would not be the same. I mean, I think in this way, it's better to explain it in this way. So the dimensions are the same, but the shape is defined by the number of elements that are stored in that view. So as you can see, C has the shape of 1 by 1, 2 dimensions, but it has only one element. So this is the difference between indexing and slicing in Numpy arrays. Now here, I wanted to give you an example very similar to lists with Numpy arrays. Because we know that in list we cannot have matrices. It's not. They are only just a one-dimensional data structure. So with this one, I'm creating a Numpy array. The elements as 1, 2, and 3. With this one, this is indexing. It will lead to a copy. With a slicing, it will lead to a view. With this one, I can change the first element, and if I can say 10, 1, and 10. But this one is a Numpy array, and the number of dimensions is similar to this one, but the shape is different. It's 1. The shape is based on the number of items that we have in each dimension. Now I'm doing the same example with list. This one is indexing, leads to a copy. This one is a slicing, but leads to a copy because it's a list. And if I change this one, A0 is 10, B and C are 1, because slicing in list will lead to a copy. Did you get this? I hope it's not very confusing.
Yes, I get it. I just have a question in the previous slide. No,
Here?
One more.
Here?
One more.
Oh.
Yes, sorry.
No
In that
problem.
part about the reference assignment, the second that is a copy, it would be
Can
like
you tell me the number of the line number?
Excuse me?
The line number. I mean, I don't know which line you are talking about.
The 4 and 2. I'm just I just want to know if a copy is the same as a value assignment, because ref is like reference assignment, right?
This one, if you just assign a variable to this one, since it is Numpy array, it would be like, I mean, it's a list, it would be like referencing. Okay, so if it was a tuple, it would not be like this, I guess. We can check that now. Let's check. I think for tuple, it would not be reference. Actually, we did this check in I mean, we checked that in the first lesson, I guess. Yeah, I agree. Let's create a tuple. My tuple and 1, 2, 3. Oh, sorry. And create another tuple and my tuple and check print ID of my tuple and ID of another tuple. Let's see if for mutable object they will be the same or not.
Okay.
They are the same. So, but let's check it for integers. Num equal 10. A equal to num. Print id of num, id of A. Even for these two are also the same. So, but the problem with this would be like this. If I change A to 2, and then the ID should not be the same. You see? So to my idea, for this moment, I can say it's useless. No, we cannot say useless because in the function it would be, they will act differently. So we can say that if you refer the objects to each other, the identifiers to each other, they will refer to the same object. But if you change a mutable object, they will still be the same. The change will be shown using both identifiers. But if it is an immutable object, then it would not be the same. No, I think I was not correct again. So if you, for example, do something like this with lists, that would be also the same. Let's do this. So if you change, if you assign something to something, the ID will change. Now both are list, even if they are tuple. I mean, the name is tuple, but they are list. So their ID now is the same. Now, yeah, they are the same. But if we change one of them just like this, then it would be a variable definition. And their ID should be different, even if they are mutable objects. Yeah. As you can see, the ID of this one has been changed, and so now they are referring to different objects. So with value assignment, we will have a new object, but if we assign two variables to each other, they will just referring to the same object. Is it clear now?
Yes. So in one part is reference assignment and the other is value assignment.
Yes. Yes. Yes, but we also have adding assignments. For example, if for here, if we do something like this, let's change the name of that because I want to do the same exercise. So if we do here, for example, my list by 5, and let's print the ID before and after. Print ID of my list. And let's do this one for tuple. The ID for the first one will remain the same, but for the second one will change. Let's do it as ID of my tuple. So it's as you can see, it's very it's list.
Yes, the second one.
So, but even here it's the same. It's very weird. So, but it should not be. We can concatenate. It's very weird. We cannot do item assignment, but if we concatenate them, they are the same. Okay, let's check. I will check this in more depth in the next lessons because it's weird because immutable object, maybe because they are sequence data types. But let's check this one. I think for integer, it should not be the same. A plus 2 plus 2 and print ID of A before and after that. Print A. Let me write it first like this to be able to distinguish. A. ID of A. Now the ID, let's see if their ID will change or not. So yeah, we can conclude that since they are sequential data types, if you add something to them, for both of them, their ID will not change if you do something like that. I thought for NumPy the ID will change, but apparently the ID will not change. But for these, integer values, they are also immutable objects. But since they are not sequential data types, when we add something to them, it's similar to changing their values. So another object will be created. Interesting, good question.
Yes. Okay, Miss. And the name of the another assignment, how is it?
Which one?
You told me that there is another assignment apart from value assignment, the reference assignment.
Yes, we have. There is not any name for them actually. We can say that we can do assignments between two variables, or we can do it between one variable and one value. Okay, but if we do it between two variables, both of them will refer to the same object value. So the second identifier, like this one will have the reference to the same object. So it means that both of them has the reference to the same object. But if we do it, we just, for example, if we have multiple 2 here, this is another way, which is one of them is a value and one of them is a variable. So now each variable is referring to that object. I mean, even if You know, with this example, I wanted to show you, even if one side is a variable, one side is a value, for this one, it will create an object, but for sequence data types, it will not create an object. Even if it is a immutable, I mean, either one of them is a mutable or immutable. I will create a summary of this one in your slides, and I think with that summary, it will be more clear. Yeah, I think I should give you a summary, because with this exercise, I may understand that, but it might not be much clear to the people who are listening to this course. I will add one slide here with your questions, and then you should check your the slides, because it is not between these slides, it will be added later. Is it okay to you? Yes,
it is okay for me, Miss.
Yeah, I think with that summary, you will get it better, because it's just some examples. Okay, let's go to the other topics. We check this one? No. Okay, with this one, I'm showing you the different functions that you have in NumPy, and you are already familiar with some of them through the previous examples. So here I'm creating an array. I'm showing the shape of that, and also showing the type of the shape. You should know that a shape is a tuple object, and as you can see, it is a tuple. I can change the shape of a NumPy array using this attribute, and I can also change that using that reshape, using the reshape function that you have here. And I can say here, I can when I need to have access to the first elements, I can use this way of indexing, or I can use this one to extract first dimension of this array, the first row of this array, and then I'm using indexing to that row to have access to these elements. But I can say that this way is better if you want to index to access to the one item of your array. With ndim, you can see the dimension of your array or your array scalar. Even if the dimension here is it doesn't have any dimension, it's just a scalar value. Since it is a array scalar, it has the same methods as your NumPy arrays. It has even a shape method. So you remember from the last lessons that we said that array scalar is an item of our NumPy array, and it has the same methods and function as your NumPy arrays. You can see the examples here. Here I'm creating another NumPy array. I can change the shape of that using reshape. I can change the value of the first elements here by -1, and if we change, if we print b, it also shows us the change, because reshape will lead to a view of your variable. Here I'm using arange to create a collection of items from 0 till 23, and when I print the ndim, it's 1, and if I change reshape it to 2, 4, 3, I can see this one here with b, and here I'm creating another array like this, and I'm saying that every item of that should be an integer and stored in 1 byte of memory. With item size, I can see the length of each elements of the array in bytes, and as you can see, it gives me it's 1 byte because it's int 8 bits in the memory. With this one, I'm saying that you can either use as array or array to create a NumPy array using another variable, and we know that here copy is equal to true, so it will gives us a copy. We can use either range or arange to create the same NumPy array. With this one, I'm using range, which is a built-in data structure in Python, and I'm creating an array using that, and I'm saying that the type should be float. And when I print that, I can see this one, it will consider all the elements as a floating point numbers. I can create the same thing using arange function. I don't need to use range function from Python and convert it to an array. I can directly create the same thing using numpy function, which is a numpy function, which is arange. How can we traverse over ndarray? It is very similar to traversing over lists. Here I created a numpy array like this. For every item in A, I print item. With this traversing, with this iterating, I will iterate over the rows of the numpy array. You can see that every row of this numpy array will be printed here. I can use unpacking while I'm traversing over a numpy array. Since every row of this numpy array has 3 elements, I can unpack it to 3 different objects and print it like this. So it will gives me x, y, z, 0, 1, 2, and like and for the other rows the same. I can use enumerating along with numpy arrays, and it will gives me the index of the row and also the rows, and I'm unpacking the rows to x, y, z. And so I and x, y, z, we can see that here, and the result would be like this. There is a function in numpy array which lets you iterate over the item of the numpy arrays, over every item, not over the rows. And as you can see here, if I iterate over this one, it will iterat over 0, 1, 2, 3, 4, 5, and the rest. And I can also do this iteration using this combination between a list and also a numpy array. And what it will do is that it will broadcast this list over the elements of the numpy array, and the results would be like this. If I n would be the elements or the items from B, and item would be the elements from A. And as you can see here, x, y, z, x, y, z, and till the end. So x, y, z has been broadcasted, over A, and we are iterating over that. There are many other ways that you can traverse. I mean, you can, the main structures, that the main functions that you can use for traversing over ndarrays are similar to this, or these ones, but you can manipulate them, you can play with them to have your favorite traversing. What is broadcasting? We said that in the first example that I gave you for numpy arrays was computing BMI for the list of weights and list of heights that we had. But we said that we cannot do that with lists. If you want to do that with lists, we need to traverse over every elements of the list and create another list to store the PMIs. But we said that is possible for NumPy arrays. We can do element-wise multiplication, element-wise add, minus, and the other things, differentiation between two NumPy arrays, or between a NumPy array and a value, a scalar. Let's see the examples to know them better, to understand them better. So this is a list. We cannot add this list by one. If we want to add every elements of this list by one, we have to use a for loop or comprehension, or so we need a loop. We need to traverse over every elements of the list to be able to change the elements of the list. But with NumPy arrays, we can do it just like this. With this one will be added to every elements of the NumPy array. We can also do element-wise multiplication, or adding between two different NumPy arrays. They have the same shape, same dimension. And if I do this one, I can achieve this NumPy array 1 multiplied by 10 and 2 by 20. It would be 40, and the rest. But we can also do this when they don't have the same shape. You can see here, this is NumPy array, and it has 4, and every row has 3 different elements, and we can add these A by with B, which only has 1 row, and the result, what the interpreter does is it will broadcast this NumPy array over this NumPy array, the first NumPy array, and add every row by this NumPy array. And the result, as you can see here, the first one is 1, 2, 3, the second one is 11, 12, 13, and the rest. How it will happen? So this is the first array, this is the second array. So this array will be broadcast like this, and then every row, every element will be added by the corresponding elements in the second array. Let's see what can we do more than this with broadcasting. So broadcasting has some rules, and I want to give you those rules through these examples. I'm creating here an array with the shape of 2 by 3, and every elements of the that are 0. So, and the B is also another object similar to A. And when I do the elements-wise multiplication between these two, the shape would be 2 by 3. Or even A by B or B by A, both of them with times by A, I mean, both of them will result to the same shape. Let's create another array. Every element of the array will be 0, but with this shape, and another one with this shape. So the first rule is that if they do not have the same number of dimensions, the trailing part should be the same. So you can see here the trailing part in these two arrays in their shapes are the same. 4, 2, 3, 4, 2, 3. And the results of these two would be 5, 3, 4, 2, 3, as you can see here. But let's here create the same A, but B has the shape of 4, 1, 3. Now you can see that the trailing part is not the same, because 2 here we have in this shape, in this dimension we have 2, but here we have 1. But this is also possible because one of them is 1. So another rule is that if the trailing parts are not the same, at least one of them should be 1. So here this one is 1. And look at this one. I'm creating another variable 5, 3, 1, 2, 3, 4, 1, 3. So 4 and 1 are not the same. 1 and 2 are not the same. 3 and 3 are the same. But here, one of them at least is 1, and here one of them is at least 1. So again, this one is possible, and the final shape would be similar to that 5, 3, 4, 2, and 3. So here the values were 0. I think it's good to do this exercise, to do this example with real, with variables that has different values, because here the values are just 0. Actually, it was really difficult to show them when we have this number of dimensions, this number of shapes in the slides. So you can see them. You can do such examples for yourself and check the values. I think you can use PyCharm and then watch the variables, then you will see them better to understand what broadcasting is doing. But it's not very common to do these things in small programs, but if you have large databases, then you may need to do these things. Or if you are working with neural networks, then you will need you may need these things to do your equations, to compute your equations. Numpy functions are a lot. We have so many Numpy functions. We have some functions which do array manipulation, like reshape, which you are already familiar with, transpose, broadcast, append, insert, delete, concatenate, and the rest. We also have binary operators, bitwise AND, bitwise OR, left shift, right shift, and then we have also string functions, add, multiply, capitalize, lower, upper. They are very similar to the string functions that we have also in Python, in a standard Python. We have also mathematical functions, trigonometric functions, functions for rounding. We have arithmetic operations, add, subtract, multiply, divide, power, mount, and the rest. We have statistical functions that probably you will use it a lot. Median, mean, average, and the rest, std, variance. We have very good functions, sort, and for sorting and searching and counting. It is very useful. I really like to, we cannot cover all these topics, but my plan was to talk about these group of functions and also these topics, I/O with NumPy, matrix library, and linear algebra, matplotlib. But I found that we really don't have much time, and we only have 2 more lessons. So I'm not sure we can cover all the topics. So I want to, I wrote these things here for you and also for myself to keep this in our mind, that we should learn these topics. We do not have time now, but we can, if we find enough time in the last lesson, I will come back to these topics and I will talk about them. Otherwise, you should do it with yourself, because these are very important topics, very useful topics, and you may need it projects. I've heard from some of my friends that they are really interested to learn about matplotlib and also SciPy. if we find enough time, we will come back to them. Otherwise, we have to find a priority and prioritize the topics and just talk about the most important topics. So we should now go to the other topics and put NumPy aside for some moments. And the next topic that we will talk about is function. Is it okay to you till now?
Yes, everything is clear.
Okay. Function. So function is a block of organized reusable code that is used to perform a single related action. So as you can see, I'm saying that it should do a single related action. So it should be really like an action. It should not be a duplicate. With function, we can avoid duplicates of the code. When we want to do an action multiple times in different location of memories, we just call this, we just write it as a function and call that function. It should not be very small. It should not be very large. It should do just one action, not multiple action. You should, you will learn this by practicing a lot, and you will understand it, what can be a function and what cannot be a function. We have some built-in functions. We already work with them. The simplest one is print function, but we can also have our own function. We can implement our own functions. To define a function, the syntax is similar to this one. We have def as the keyword, the function name, and the parameters, colon. We have here first, it's an optional string that you can write here as your document. You can document what your function is doing. And then your the body of your function, and the last one is the return statement. It can return an expression, or it can be without anything, just a return. The default return value would be none. Either you write a return without an expression, or you do not write anything here. The return value of your function would be none. So this is an example of a function. This is not a good function. This is just an example because it's not a good function, because it's just we have print function. I'm just calling the same function in another function. So it's not a good function. Just since I wanted to show you how a function will be is written, I give you this example. So as you can see, this is the doc string that we have. It says that this prints a pass string to this function. This is the parameter, this is the name, this is the keyword, this is the body, and it doesn't return anything, but the default return value would be none. So if here I'm calling this function, and if I here write a equals print me, the value of a would be none, because the default value is none. But you don't need to write that. You just call it like this, and it will print the first message and the second message for you here. Let's see another example. I can say if you only have one command here, without any docstring, without any return command, you can write it in one line. Don't recommend that, because it makes your code dirty. You should follow the same style of coding in all of your codes. And if your style of coding, for sure, your style of coding is to have the commands after this colon in the next line, you should do it even when you have only one line of code. You can call this function using this way. Either you can just write my string here, or you can write the name of parameter equals to this, to just call this function. Here I want to say that you can also write the body of your for structure in front of the colon if it only has one statement. But again, similar to function, I should say that I don't recommend this. But you cannot write this one here, even if for is just one statement, but you cannot write it here in front of def because it's for. So this is very unique to Python, that in Python we can have nested functions. We cannot have this in other languages. For example, in C++, if you want to have nested functions, you have to use Lambda functions. But here in Python, you can have nested functions. But how? This is a function that we have, the name of the function, def keyword, the arguments, colon. Now here, this is inner function. I'm using def keyword, name of the function, parameters, colon, the body of that. And I'm returning, this return is for this one, and I can understand it based on the indentation. So with this one, I'm saying that this function should return this. So if I enter here my func2 entry, so 2 and 3 will come here, 2 will be passed to this inner function, it would be power of 3, it will be, and the result would be 8 here, and I can also, the 3 will be also passed to here, and this one will call the inner function, and the result would be 27, and 27 will be added to 8, and the return value of the outer function would be 35. But we do not have access to this inner function from outside of this outer function. This is local to this function. We need to talk about the scope of variables in the next lessons, but I decided to postpone it to after learning modules and classes, because a scope is related to the program. But for you should know that the scope of this inner function is the outer function. We cannot access the inner function from outside of this function, this outer function. But we will discuss about them later when we are talking about scope of variables. We said that in the first lesson that everything in Python is an object. We can create an instance of a function object, because function is also an object. So this is the same example that we had in the previous slide. We printed 35. Now I'm creating a function of this function by assignment. When I print this one, my instance 2, 3, it gives me 35. When I print my instance 1, 3, it gives me 28. So my instance is now like my function. It's another function. It's we can have access to this function through this identifier as well. And if I print their IDs are the same, because if you remember from the first lesson, we said that classes, modules, functions, they are all immutable objects. So they are both referring to the same object. So their IDs is the same. And if I also use the is keyword, it will say that my instance is my func. It will return true for that. But if I do item assignment for that, because it's when item as okay, I think in the summary that I will will add to these slides, I will find a name for them to be able to distinguish between when we have assignment between a variable and a value and variable and another variable. Here we have assignment between a value and a variable, so it would be it will lead to a object creation. Now with my instance, I can have access to this function and the result would be 35. But my func is no longer a function, is now is an integer. It's an integer now. So as you can see, the error it says that int object is not callable. You cannot call an integer. So like other Python objects, a function has its own methods, function, and attributes. So you can, through the name of the class, myfunc, for example here, with myfunc, if I write myfunc.func name, it will give me the name of the function. If I write .func code, it will give me the code of the function. Func defaults, func doc, func low bars, and so forth. So unlike the functions that we have in other languages, in Python functions are objects. They have their own methods and building methods and attributes. So we can use them and also we can create another object from a function. We can assign them together or and so on. We have function arguments in functions, and we have different ways of passing the arguments to the functions. In C++, I mean, the ways that we have here are different from other languages. In C++, for example, we have call by value, call by reference, call by const reference, call by, and the call by pointers. But here we do not have them. They are different from what we have in other languages. But let's see what are they. What they are. Positional arguments, which are required, we can also call them required arguments, keyword arguments, default arguments, variable length arguments. So positional arguments are similar to what you saw in the previous slides. So they should be in the correct positional order. Keyword arguments, this allows you to skip arguments or place them out of the order because the Python interpreter is able to use the keywords provided to match the values with parameters. So let's see how. We have a function here. It has two parameters, name and age. It will print name and it will print age, and then it will be returned. With this one, I'm calling this function age 15, name Mickey. So either I can, for example, I will explain the difference with positional arguments in the next slide. But now with this one, let's see what keyword arguments is. I said that with keyword arguments, you can place them out of the order. The order here is name and age, but with the keyword arguments, I can write first age is equal to 50, name is equals to Mickey. So the order is not the same as the order of the parameter. The order of the arguments are different from the order of parameters. Let's see the difference with positional arguments. The same function. How I can call this function using positional arguments and keyword arguments. We have 4 different ways now. This is more positional ways. For both of the parameters, I'm calling the function, I'm passing the arguments in a positional way. The first one, name is Mickey, age is 50. With this one, both of them are passing using a keyword. The keyword is name is Mickey, age is, age is 50. But here with keywords, I can change the order. I can either write age 50, name Mickey. So both of them are correct. Both of them are keyword. I can do a combination of passing argument using positional way and keyword way. So this is positional. The first one is positional. The last one is keyword. But if you are doing a combination of positional and keyword argument passing, you cannot have keyword as the first one. I mean, we can say that we cannot have positional arguments after keywords arguments. This is not possible. Even if the order is correct, name is here, name is equal to Mickey, but since age is passing using positional way, it will give us a syntax error. So positional cannot be after keyword arguments. What is default arguments? A default argument is an argument that assumes a default value if a value is not provided in the function call for that argument. So here the function definition has slightly changed. I defined a default value for this parameter. So we can use the 4 different ways that we had in the previous slide to call this function. So these are the same. And still we have error with this one because positional comes after keyword arguments. But we can also do this one. Name is Mickey here. I don't provide age, and the default value for age would be 35. And as you can see here, this is name is Mickey, the age is 35 because the default value is this one. I can also do this with keyword. Keyword is name Mickey, and I do not pass age. And the default value will be 35. It is not possible to define a default argument for one element when for one parameter when the following parameter don't have a default value. For example, this one is wrong because we are defining a default value for the first parameter, but the second parameter does not have a default value. This will give, if I run this piece of code, this will give us a syntax error, and it says that non-default argument follows default argument. So how can we just saw that we can skip, we can ignore some parameters if we have a default value for them. But how can we skip some arguments from the middle when we are calling a function? I'm creating a function here. The first one is name, the second one age, the third one is weight. 2 of them has a default value. And I'm printing them here. With this one, Mickey would be, these are positional arguments. Mickey name age would be 50, and the default value for weight would be 70 because I don't pass weight here. With this one, I'm saying Mickey positional argument will be passed to name. Weight will be passed to this. Weight is 70. If the default value of weight is 70, but I'm saying it should be 50. But I skip age here. I didn't say what age should be. So the default value will be considered for age. I can do this also passing the arguments using dictionary, and the dictionary can help me also with skipping some arguments. So I have a dictionary, the keys are the parameter, and the values are the values that that we are going to pass to our function. And we pass this dictionary using double asterisk. So with this one, I'm also skipping age, and the default value for age will be 32. So these are different ways that we can pass the arguments. We also have another way, which is more advanced way, is this one. So in the parameter section, we have positional arguments. We have an argument, a tuple of arguments, which are defined by an asterisk, and a dict of keyword arguments, which are shown by a double asterisk, and the rest are the same. Let's see in this example how they work. But before that, did you get to all the keyword arguments and positional arguments and default arguments?
Yes, I got it.
Okay, very good. I might be a bit fast, but since we do not have time a lot, and I want to cover all topics today, I mean the topics that I prepared, that's why I'm a bit fast. So if you felt that I'm too fast, you can ask me to teach more slowly.
Okay, perfect, but it's okay.
It's okay, okay, very good. And so here this example show us how can we have a variable length arguments, a function with variable length arguments. This is a function that I defined. It has two positional arguments, and then a tuple of arguments like this, and a dictionary of keyword arguments like this. In the body of this function, first I said that what this function does, and then I print the first and second positional arguments. Then here I'm printing all the elements of this tuple, and now here I'm showing the key and the value of all the items of this dictionary. Let's see what will happen if we call them in these ways, if we call this function with these ways. In the first one, I'm calling this function with only two values, 70 and 60. So print this one, the result of this function. arg1 would be 70, arg2 would be 60, because positional arguments are given here, are passed to this one. And the tuple and the dictionary would be empty, Let's see if we call it like this, 70, 60, 50 and 80. And if we do this one, arg1 70, arg2 60, and these two elements would be for this tuple, and the keyword dix is still empty. Let's call it like this: 70, 60, 50, 80, and A equals 5, B equals 15. And as we can see, arg1 70, arg2 60, the tuple like the previous, and the dictionary is A5, B 15. So keywords arguments belongs to this. Positional arguments, when we have a positional parameters here, belongs to this, and the rest belongs to this tuple. And let's see here, if I only put 70 and 60 and A 5 and B 17, then we will see that the tuple is empty, the dictionary has this one. But if we do something like this, if we want to try to call this function with 70, A 5, B 15, it gives us a type error because its arg2 is missing here. So in summary, we can say that we can have variable lengths of arguments, and we can pass them through star and double star. Double star belongs to keyword arguments, star belongs to positional arguments, and these the first positional arguments will capture the first positional arguments in the call. So this is the way that we can have a function with variable length arguments. Is it clear to you?
Yes, and it's interesting that we can have different type of variables.
Yeah. And somehow it can be also confusing.
Yes.
So, but practice makes perfect. So we will be perfect if we practice a lot. So Python does not support function overloading. What is overloading? I don't know if you are familiar with other languages or not, but overloading in C++ or Java, they are similar their definition is this. When we have two functions that their name is the same, but their parameters are different. Either the number of the parameters are different from each other, or the type of the parameters are different from each other. But this is not possible in Python. I tried this one in Python to see if we have overloading or not. This is a function that I define. It only receives one parameter. It only has one parameter, which is a str here. And I'm showing the every character of this string with this for. I'm creating another function with the same name, but it has two different elements here. Two different parameters here. In C++, this is possible because these two would be different functions in C++. Because in C++, a function will be distinguished from another function using its function signature. And function signature is the name of the function and the number of parameter and the type of the parameter that it has. But in Python, the signature of a function is just its name. So if you write something like this, you are overwriting this function. You will not have this function anymore. So with this one, print char, I can print hello Nasty, as you can see with this style. But when I try print char with Nasty, which only has one item, it says that it needs another argument because the interpreter can only see this one, the second function that is defined. So that's why we say that we do not have function overloading in Python. But we have function overriding, which we can see later when we get familiar with classes. But I saw in some resources, when they are explaining that topic, they will refer to that topic as overloading, but that's not overloading, that's overriding. Because if you go to job interviews, they usually ask you about what is the difference between overloading and overriding. This is a typical question that they will ask. So it's not interesting to confuse one of them with the other. You should know both of them, and you should know that you do not have overloading in Python. We are familiar with mutable and immutable parameters. We saw that they have different. They are behaving differently from each other, and so they are also acting differently in function calls. So we know that objects, when they are passed to a function, they are passed by reference. Like the question that you just in this lesson you asked, we saw that when we assign a variable to another variable, they both will refer to the same object. And so again, when we are passing a variable to a function, they will be passed by reference. So they will refer to the same object. But when we change them inside the function, depending on the fact that if they are immutable objects or mutable objects, they will act differently. So how they are different from each other? We said that both of them will be passed to a function by reference, but a new local object will be created if you try to change immutable objects inside a function. So if we change them, we know that if we change immutable objects by assignment or like an integer, the example that we just saw, if we added by 3, we had an integer of 2, whose value was 2, we added by 1, and we saw that a new object has been created. So inside the function, this is also the case. So if you pass an immutable object to a function, it will be passed by reference. But if you add it, for example, if it is an integer, if you add it by 1, a new local object will be created inside that function. And then it would be different from the variable that you passed and you have it outside the function. What about mutable objects? If you change a mutable object inside a function, the object itself will be changed. A new object will not be created. So if you pass a mutable object, if you change it after calling the function, the variable that you just passed will also change. An object assignment between a variable and a value, whether it is a mutable or immutable, inside a function leads to a local object creation. I just explained everything in theory. Let's see their examples. Here I'm defining a function. This is a function. And its parameter is a list, tuple, and an integer. I'm showing the values of these parameters inside the function before doing any change. I will show them, then I will show their IDs. One elements of this list by 40. I cannot do this for a tuple. I will add the elements of, I will add this integer value by 40. Then I will show this list and this num after these two changes. Then I will show also their IDs. The next change, the second change that I made, I assign them to a value, not a variable, to a value. And as you can see, I'm showing also their values and their IDs after these changes. Here, I'm creating a list with these elements, a tuple with these elements, and an integer with this value. I'm printing these three and also their IDs before calling the function. As you can see, these are them and these are their IDs before calling the function. I call the function. When I call them, first I will show them before doing any change, and also their IDs. As you can see, their IDs are the same. So this shows that they are passed by references. So this one is mutable, these two are immutable. So there is no difference between them. When you pass them, they will be passed by the references. I'm changing them, and now I'm showing them values inside the function after the first change. So I only changed the list and the num, the integer object. And as you can see, the ID of the list is the same because it's a mutable object. We are still working with the same list here, but the ID of this integer has been changed. We're not working anymore with this num. Now a local integer object has been created. This object is local to this function. I did this change, and now I'm showing them these parameters, these arguments, after this change. You can see that they have the new values, but their ID, the ID of all of them has been changed. The ID of tuple was this one, the ID of this one was this, has been changed, and the ID of this one has been changed because we saw that this will lead to new objects. Now we're not, from this moment onwards, we are not working with these lists. Okay, the function will return. Now I'm showing them, I'm showing my list, my tuple, and num after calling this function. And as you can see, the change that I have in my list is this one, the first change. I do not have the second change because the second change leads to a new object. My tuple has not been changed, and my integer also didn't get changed because they are immutable objects. So this is the effect of mutable and immutable object. When I was talking about them in the first lesson, I told you that in some resources they don't even talk about them, but I noticed that in my based on my experience, when I was working with the functions, I noticed that what is happening here. Why, when I'm using list sometimes it changes, sometimes some data structure doesn't get changed. So what is happening here? Then I noticed that there is a concept which is mutability and immutability in Python, and that affects all the applications, all the structures. So that's why we need to know about mutable and immutable objects. And also with assignments and your good questions that you ask in the in this lessons, I will surely provide you with some summary of what we learned till now in one of the slides, and you can learn them from the slides. Okay, before going to the next slide, is it clear for you?
Yep, everything is clear for now.
Okay, very good. Oh, I think I made a mistake here. Okay, it's stuck. Okay, we learned how to define a default value for our arguments. Let's see how we can define these default value for mutable objects. In this function, I have two elements. Something that I forgot to say here, in this one, I used a keyword. str is a keyword in Python, and it's not good to use that. This is a mistake, and I should correct that actually. You can do something like this. If it was C++, you couldn't do that because it's not possible to use the keywords of a language. But in Python, it is possible. But from now onward, if I now I want to define a str object and use the str type for in a NumPy, then I overwrite. I mean, with this one, I overwrite it. Sorry, I've overwritten the keyword that is defined in Python language. So it's not good to use the built-in keywords of the language, because then it may lead to some bugs and something. So don't do this. It's not. It's just a variable here, but it's not a good name for my variable. Okay, then come back again here. Here, this is a function that has two different arguments. It has one list and one tuple. One of them is mutable and the other one is immutable. And I'm printing the ID and the value of each of them. With X here, I'm appending 1 to that list. I'm also appending 1 to this tuple, and I'm printing that. And I'm calling here this function twice, func, and here this func. With the first one, when I do that, before this change, I can see an empty list, an empty tuple, and after this change, I have a list with 1 element and a tuple with 1 element. The second time that I'm calling this function, when I print that before doing the change, I can see that the ID of the list is this one, as you can see, but it's not empty anymore. It has, since it is a mutable object, it has the last elements that it had in this function. And but this is not the case for tuple. For tuple, it's empty. And if, as you can see, the ID is the same. But as I explained in the first slide, the similarity between these two, it's because just the garbage collector has been deleted this one and this one and replaced the new object with this one. So they are not the same. They are another object. And so after doing this change, I can see one here and here just one element. So we can say that if you use this way of defining a default value for your function, for your mutable objects, in every call of your function, it will not use the default value only for the first call of your function. It will use this default value, and in the next runs, it will uses the existing object. But if you want to define a default value for your function, you should, for your mutable object, you should use this structure. I only replaced these two brackets with non-value here, and I added these two lines to my function. And it says that if x is none, and then create a list here. And now if I call function for the first time, it is none. And when I run it, when I print after x is none, it will create a list for me. And also this would be a tuple. I will change it by 1. It will be a list which has only the elements of 1, and also for the tuple. In the next run, again, it will be none, because none is an immutable object, and it will check if x is none. Then it will define a list and set it to x, and so the second run of func, after this change, we have 1. So every run of this function will lead to the same result, you can see. But here, for this one, since I use this default value, every run has different results for this mutable object. So this is the way that you can define a default value for your mutable objects. Another example here, this is similar to the previous one, and this is the slide, but now I'm defining a list and tuple outside of the my function, and with this, and I'm calling this function with this. And as you can see here, before this one, when I print that, it's an empty list and it's an empty tuple. And x is not noun, it's not noun, and when I print that, I can see this. So this is the same. It is, the condition is not true here. And then when I print ID of them, when this print would be similar to this print, as you can see here. I do this change similar to the change that we had in the previous slide, and I will print that. It will create, it will add one element to this list. It will create another tuple and add this one. You know what is strange? I think it's better not to talk about that, but I will add that slide because now it's creating another object here, and we saw that this was not created in our first example in this lesson. But I will show you in one slide and explain that later to you. Okay, but it will create one object here, and it's different from the other one. And outside of this function, when I print x and y, x has been changed, but my tuple didn't get changed. because we saw that for immutable objects, if we change them, the change will not be reflected in the outside functions. But what about to calling this function again with x and y? Since x is now 1 and y is empty, again, the function will return these three things to me, but for this one, after this function, another element has been added to the list. So you can see that the effect of mutable and immutable objects, and every time that you are calling your function with a mutable object, the change will be saved to your object. You are still working with the same object, but with immutable object is every time you are creating another object, and the change will not be reflected to the past object. But if you don't want to reflect to, I mean, if you don't want to pass them by reference, pass a mutable object by reference, you can create a deep copy of your mutable objects. Then here you are passing a copy of x, so it's not anymore the x that you had here, it's another object, and if you change that, the change will not be reflected to x. So you can work with them more and to understand it better. And okay, I will show you later, but in your exercise as your homework, I ask you to do this slide and also the slide in 28 for Numpy arrays to see what will happen with Numpy arrays. Numpy arrays also are immutable objects, but they have some characteristics of mutable objects as well. I mean, sorry, they are mutable objects, but they also have the characteristics of immutable objects. I mean, they can be changed, but they are located in one continuous location of memory, like immutable objects. If clear, we can go to the anonymous function.
Yeah, it is clear.
Yeah.
So far.
Okay, very good. I think we have anonymous functions, and then we can go to the classes. So it's good. We had good progress.
Yay.
So anonymous function or lambda function are some functions that you can also find in other languages. But the lambda function again in Python are different from the lambda function in other languages. The syntax to define a lambda function is this. You have this keyword lambda instead of def keyword. You have your arguments, and then you have one expression. You can use the lambda keyword to create small anonymous functions. Lambda forms can take any number of arguments, as you can see here, but they return just one value in the form of an expression, as you can see here. They cannot contain commas or multiple expressions. But you can see in my example how you can return multiple elements using one value. So you can return one item which includes several values. So when we are saying that one value, the value can be even one list. Lambda function have their own local namespace and cannot access variables other than those in their parameter list or those in the global namespace. We will talk about global namespace, local namespace when we learn modules and classes. After that, we will talk about these topics as well. But for the moment, you should know that global scope is the scope of the whole of your program, and everything that you define in that global scope can be accessed via these Lambda functions, or you can have access to the arguments that you have in here. Also, it appears that lambdas are a one-line version of a function. They are not equivalent to inline statements in C or C++. In C or C++, we have inline. We can define, we can either put the keyword inline before the name of a function, or we can write our function in one line to make the compiling process faster. But this is not the case with Lambda function in Python. So they are not equivalent to the inline function in C++. Here I'm creating a Lambda function. This is a Lambda function. It has 2 arguments and it has one expression here. And so it will receive 2 arguments, add them, and it will return that. I do not need to write here a return. The result of this expression will be returned. And now I'm saving that result in a location of memory, and using sum, I'm referring to that location of memory. And now sum is a Lambda function, and I can call this Lambda function using sum with 2 values and print it here. So 10 and 2, 20, it will lead to 30. 20 and 20, it will lead to 40. So this is the way that you can define a Lambda function, and you can call a Lambda function. We said that we can have nested functions. So it's a traditional function, it's a function that we can, a standard function that we can have. I have a nested function which receives 2 arguments, and it will return the sum of these 2 arguments, which are power of n, which is power of n. N is the input of the outer function, and I'm returning this nested function. It might be really strange to you, but we said that everything in Python is an object. Functions are an object, are objects, so we can return them. We can create an object of type of function, and we can refer to them using some variables. So now I said to you, if you remember from nested functions, we do not have access to the inner function from outside of this outer function, but we can return the inner function. I'm returning the inner function here now, but let's use them. I'm creating an object of type of this function. The elements of that is 1. The arguments of that is 1. So tfunc now is this function, and the first elements of that is 1. In fact, what is happening here? I'm calling this function by 1. It will return me this nested function, and this nested function is arg1, arg2, n is replaced by 1. So every time, if I call tfunc with 10 and 20, it will be just the addition between arg1 and arg2, between 10 and 20. So it will gives me 13. If I put here traditional func 20, it will return me this inner function, and this inner function has 2, n is replaced by 2, and the arg1 and arg2 is 10 and 20. And as you can see, the result would be 900. But I could write this one in much cleaner way, using lambda functions. I have a function here, and I'm returning lambda arg1, arg2 like this. So now I can create func1 like this one with 1, and f10 and 20, it gives me 30, because it's f now is a lambda function, and the elements of that 10, the arguments of that 10 and 20, and func2 is a lambda function, and n in which n is 2, and the arguments now is 10 and 20. So this is the capabilities that you only have in Python, and you don't have it in other languages. You may find, you may think that, okay, what's the application of this anonymous function? Lambda functions allow you to write function in a quick and potentially dirty way. But because dirty way, because we are writing all the codes in one line, and somehow it can be dirty. But there are situations when they come in very handy. You are already familiar with map function. When I was discussing about comprehensions, I showed you that you can do one process for every elements of one sequence, every elements of an iterable. There, when I was explaining that, I referred to map. But just for the sake of integrity, I want to also explain that here. Map is a function which applies the function, this function, over all the elements of this sequence. In such cases, it's more interesting, instead of defining a function and using that function in the name of the function here, instead of that, we can just write a lambda function like this and put the sequence here and get the results. Print the score. If we print the results of map, it would be a map object. If we convert it to a list, we can see the results here. So we could also write this function like in a standard function here and write the function here. But it would be more cleaner, much better if you just use a lambda function here. It would be just one line of code. It would be quicker. So this is one situation that you can use lambda function. The exercise. So till now we got familiar with Numpy Arrays. Still, we have some other topics that we can discuss about in Numpy. But if we find time in the last lesson, we will discuss about that. Otherwise, you should study. I really recommend you to study them. And we also got familiar with functions. We are familiar with comprehensions. We are familiar with slicing, negative indexing, lambda functions. So these are very good topics that are very unique to Python, and it's really good to know them. Considering all these things that you know, you should do these exercises. The first exercise says that, given the following data, this one, write a Python program to add 1 to all the integer numbers. Add 1 to this. So the expected result would be this one. I want to have a piece of code whose input is this one, and the output whose output is this. But I want you to exercise, to practice more with this exercise. So I asked you to provide at least 4 solutions for this one. Use lists, use Numpy arrays, tries to use map and lambda, try to use comprehensions. Using each of these concepts, you can provide a new solution. The other one is, given the following data, all the elements are integer values, write a Python program to add 1 to all the second numbers in each subarray. These are the subarrays. I want to have the input would be this one, the output would be this one. Again, try to practice with that, with different concepts that we have learned during these lessons. In the slides 28 and 30, we have worked with different topics. We have worked with how to pass list, mutable and immutable objects to our functions. I want you to do the same, to implement the same examples, but with Numpy arrays, and see the effect, how a Numpy array works if you pass them to a function. Okay, the next topic that we should discuss about is classes. So we know what a function is, we know the data structures, the built-in data structure, the NumPy data structures. Now it's time to learn more about classes. We cannot cover all the topics about classes in this lesson, but we will be familiar with the fundamental concepts in classes. What is a class? A class is a user-defined prototype. It's a prototype. Don't confuse that with other variables. A user-defined prototype for an object that defines a set of attributes that characterize any object of the classes. The attributes are data members, class variables, instant variables. So data members are either class variables or instant variables. And it's also a class has some attributes which are data members, methods, and access via dot notation. But let's explain some keywords, some vocabulary, some words in the vocabulary of in the dictionary of classes. Instantiation. The creation of an instance of a class is called instantiation. We said that class is a prototype for an object, and with instantiation, we create an instance of that prototype. It leads to an object. What is an instance? An individual object of a certain class. So it's an object of the type of the class. It would be an instance. An object that belongs to a class of circle for example, is an instance of the class of circle. So we have a class whose name is circle. We can instantiate an object of this type, and we say the name of that object obj, and we can say that this object belongs to the class of circle. What is a method? A special kind of function that is defined a class in a class definition. So method is just a function which is defined inside a class, but it's somehow different from the standard functions that we have in Python. We will see how they are different. We have class variables, which are very similar to static data members in C++. If you are familiar with C++, you can say that class variables are static data members in C++. It's a variable that is shared by all the instances of a class. So it's not only for one object, it's not only for one instance, it belongs to the class. Since it is belonging to the class, it's shared by all the instances of that class. But what is instance variable? A variable that is defined inside a method and belongs only to the current instance of a class. So we define some variable inside the methods of the class, and those variables are instance variables because they are belongs to the objects, to the instances. They are not belongs to the class, so they are not shared between different classes. Every classes has can have, we cannot say it's not obligatory, but every instance of that class can have that instance variable, but the value of that can be different because they belong to the instance, not to the class. What is a data member? A class variable or instance variable that holds data associated with a class and its object. So we are familiar with the terminology of classes now. Let's see how we can create a class. This is a this is a syntax. We need the keyword class, the class name. The style of naming in Python is like this. It's not obligatory, but it's recommended to have a capital letter with them, and also using capital letter between the separate names. The documentation string for this class and the class body. We can access to this documentation string using the class name.doc. This is also the case for functions. If you define a doc string for functions, you can also access to that doc string using the attribute doc, the function name dot the function name dot and this attribute, because we said that classes, everything in Python is an object, and so they have their own attributes. This is also the case for classes. So here I'm creating a class, the name of the class, colon, the doc string. This is a class variable, which is defined inside the class, outside of the functions. This and the instances of this class. All the instances of this class we have the same value for this class variable because it belongs to the class. And here, this is a class constructor. So we have a method whose name is this with double underscore and double underscore before and after that. And the first element is self, and the first argument is self, and the rest is the arguments of the function. This is self.name equals name is an instance variable, which belongs to the instances of the class, and every instance of the class can have different value for this variable. Also, this one is an instance variable, and employee.empcount, and I'm adding that. So what is happening with this function? The class constructor will be called when you are creating an instance of the type of the class. So in other words, when you are instantiate an object of this class, the constructor of the class will be called, and you will pass these two arguments to the constructor. What is happening in this constructor? Two instance variable is creating for that object and for that instance, and they are assigned with the past values, past arguments. Here we said that mcount is an element, is a class variable. So I can have access to mcount using the name of the class. I'm adding that by 1. With this structure, I can count the number of instances that are instantiated from this class, because this is, if you think more, you will understand what I'm saying, because in every, because this is a member of the class, and the value will be shared between all the elements of all the instances of this class, and every time that is every time that one instance is created, this class variable will be added by 1. So then we know that the number of instances that got instantiated from this class. This is a class method, and a class method at least has one argument, which is self. This is similar to this pointer that we have in C++, if you are familiar with C++. And with this one, this is also a class method, and I can, with this one, I'm printing this class variable. With this one, this is also a class method, and I can print these two instance variables, as you can see. Here, I'm creating the first object of employee class. This will call the constructor name and salary. I won't write self here. It is just a way that shows that this is a class constructor. This is a method of the class. And an object will be created here. With this one, I'm creating the second object of this class. When I call display employee, it will show me this one, name and salary. Name Zara, salary 2000. similar to what we assigned in the constructor of this class. I can also call the same function for second. It will give money, salary, 5,000. So as you can see, name and salary are instance variables. So they have different values for different objects, for different instances. I'm here showing, I'm calling empcount, which is a class variable, to see the value inside empcount. It says it's 2, but I can also access emp1.salary to see that 2,000. But I cannot have access to salary using the name of the class. Why? Because salary is an instance variable. It's not a class variable. So it will give me an attribute error, and it says that this type of object has no attribute salary. Let's see another example, and in that example, I will discuss about these commands and also class variables and instance variables. So instead of using the normal statements to access the attributes, you can use the following functions. We have some getter and setters, and these getter and setters has 2 arguments, at least has 2 arguments, the object and the name of the attribute that we want to access. With this one, we will get the value, and with this one, we will set this value to this attribute of this object. With this one, we are checking that if this object has this attribute. With this one, we are deleting this attribute from this object. And here, if the attribute does not exist, then it would be created. So if this object does not have this attribute, it will create an attribute with this name and set the value of that to this value. Let's see this example. The class definition is similar to the previous one, but not exactly the same. I have a class variable here. Also, name is a class variable here. I have an instance variable which has the same name as my class variable. These two are different from each other. One of them is a class variable, the other one is an instance variable. I showed you here, I added another function, another class method here, which shows me the name of the class. So this class variable, this class variable, and also this instance variable, this one. So this method function will print both of them for me. So keep this one and this one in your mind, and to see the how when we call them, what will happen. First, I created 2 elements, employee, 0 and money, with these 2 values. When I print the first one, display name, it's the name of the class is employee class. The instance name is 0. So when this shows that when the constructor is getting called, name will be assigned to the instance variable. This name will not be changed, as you can see. When I create the second one, again, the instance variable has been changed, and the name of the class is still the same. I printed here the instance variable of both of them, Zara and Money, and I printed the class variable of both of them, mcont. So, although we said that class variables belong to the class, we can have access to them through the name of the instances. They are also for the instances. But we saw that we cannot access to the instance variables through the name of the class. We saw that we got an attribute error. So here I'm using this one. I could also directly change the this one by emp1.name equals to John. I could change the name of emp1 to John, but I wanted to show you how you can also use set attributes, this function. So that's why I'm writing this here. So with this one, I'm changing the name of this object to John, and I display the name of emp1, and as you can see, it's John. When I do this one, again, the instance variable whose name is name will change, and the name of the class is still employee class. And this change will not change the second object. And it's this for the second object, we have still money and employee class. For employee, now I'm changing the class attribute. Name to emp class. Now it's a class variable. We said that classes have not access to the instance variable. So now, so now they are access to the class variable. And when I change this, when I call this function, as you can see, for both of the objects, the class variable has been changed. So if you change the class variable, since it is shared between all the instances of the class, we will see the change through all the instances of the classes. Let's do this example. Here I'm changing empcont. For empcont, it was a class variable. We didn't have an instance variable with this name. We only had one class variable with this name. I'm changing that through the name of the class, and I'm changing that to 10. When I show that, I will see that either from emp1 or emp2, I can see it's 10. When I also print emp1.cont, emp2.mcont, I also can see that. I can also, now I'm trying to change the empcont, the class variable, using the name of using this instance of the class. But this is not possible because we can only change the class variables through the name of the class. If we do this one, it's similar that there is not any instance variable with this name. So an instance variable with this name will be created for this instance of this class, and the variable value will be 20. When I show this one, emp1 display con, it will show me this. When I show emp2 display con, again it will show me this, because both of these two, this method is calling the class variable, not instance variable. But if I use emp1.empcont, this now, since emp1 has an instance variable with this name, it will use this one, not the class variable. But for emp2, since it doesn't have an instance variable with this name, it will call the class variable. So that's why you see here 20 and 10. To my idea, they are more confusing than C++, because to me it's very dirty. In C++, you know what you are doing, you know what is happening. For example, the difference between these two is just one word, self dot something. You cannot, in C++, you cannot add one attribute to one object after its creation, but here you can do that. You have more flexibility in Python, but this flexibility may lead to some confusing structures. But this is the definition of the language. If we want to be a Python programmer, we have to master all these things. Now here, if I delete the attribute of empcont from emp1, it will delete the instance variable. And if I call display cont from emp1 and emp2, both of them will show 10 because both of them are calling the class variable. And if I call here emp1.count, emp2.empcont, both of them will show me 10 and 10, because now emp1 does not have an instance variable with this name, so it will call the class variable. If I try now to delete empcont, it will give me an attribute error because emp1 does not has an instance variable with this name. But I can delete a class variable through the name of the class. So if you want to set class variable, you should use the class name. And when I show display cont, there is a problem here. Yes. This one, yes, it's okay. When I try to print this one, it will give me an attribute error because I deleted the class variable empcont, which is called by display cont. So this line of code will give me this error, and the other line of code will not be ran. Just to show you display cont in the previous example, you can see that it will call the class empcont. So this is the whole thing that we wanted to discuss in this lesson. Please do the exercise. I am very, very busy, as you can saw. I had a call from my supervisor now. We are doing research at the same time, and I'm working day and night to be able to also prepare the material, to check the exercise, to do my research. It was not supposed to be like this. I was supposed to just do this one in these months, but these weeks, I mean, because of, I mean, something that happened for my research, I was waiting for something, and because of the timing, I mean, everything got changed. So I have to do both of them in parallel, and because of that, I don't have much time. But I really recommend you to do the exercise, even if I cannot correct your exercise very fast. I cannot reply your email fast, but it's good for you to do it. You will learn it, and as you saw, when you do your exercise yourself, some problems, you may find some problems, some difficulties. You may find some good and interesting information. So it's good to do that. And do you have any questions? We will before listening to your questions, we will continue talking about classes. It's just we just only talk about some fundamental topics in classes. We will discuss about private, public functions, overriding, and the rest in classes in the next lesson.
Okay, so we will have one more lesson, won't we?
Oh yeah, I should actually talk with you. Let me see. Oh, sorry.
Yes, no problem.
Yes, we have 2 more lessons for our Python class, but both of the classes are in the next week. But I cannot really handle. I need to both of the classes to cover all the topics in Python. But I cannot prepare the material for both of them in 1 week. So is it okay for you to have these 2 lessons in 2 weeks?
Yes, no problem for me.
Okay, very good. Do you have any question now?
About what we saw, just a comment, because as you told me, it is an interesting hint to know that in the interviews for jobs, they ask you what is the difference between overriding and overloading. Mm-hmm. And yes, I'm not familiar with C++ with the classes C, mm-hmm. because I just saw C in my high school, but I saw Java programming, mm-hmm. So I know a little bit about this from classes and overloading. So it is interesting, the difference between Python and Java, because I think that in Java is almost the same that in C++. I'm not sure.
They are very similar.
Yes, so that, and my only question is about the classes in Python. We always need to initiate, create the constructor with the 2 underscores init and 2 underscores, right?
Yes, exactly.
Okay, yes, because in Java it's the same name as the constructor.
Yeah, exactly. In C++ is also like that, but in Python the syntax is different for constructor. Yeah.
Okay.
But
perfect.
Did you get overloading in this lesson or not?
Yes, I got it. I understood.
Mm-hmm. Okay. But for overriding, we are not ready to discuss in this lesson. I mean, we can talk about that in the next lesson probably. And at that moment, I will also refer to the difference between overloading and overriding.
Oh, perfect. And are we going to see the inheritance? I'm not sure if is the name.
No, it is.
Okay.
So yeah, we will discuss also about inheritance in the next lesson. So in the next lesson, I will talk about classes. We still have many other topics that are left in classes, like private, public, protected. We have these things in C++, for example. Here they are different. The way that you want to define a private function, again, is using some underscores. You do not have the word
Right.
protected or public, private here, but you have other ways to define them. And also we need to discuss about inheritance. And I'm sure there we will have some problems with how Python manage the references. And how can we have a child inside a parent. So we should discuss about that one. And then overriding. It would be great if I have time to talk also about modules and the scope of variables. So if we cover all these topics in the next lesson, in the last lesson, I can talk about the topics that are left behind from Numpy and Matplotlib that some of my friends are asking me to teach that one as well. And I myself like to talk about PyTorch as well, because I think for your master thesis, you will work with deep learning. Even people who are working in chemistry or other major of studies, they usually use deep learning nowadays. So it's good also to talk not all the topics inside that, but at least to get familiar with PyTorch. I'm already familiar with PyTorch. I'm implementing my ideas, everything in PyTorch, somehow also in TensorFlow. But I found that PyTorch is more, to my idea, is better than TensorFlow. So if we find time, we will talk about these topics in the last lesson. I have also multi-threading in my mind, but I think we cannot cover all of them in 6 lessons.
Yeah. Okay, but if we can cover the most, it will be great. Great.
Yeah, if we can't, if we have time, yeah. Actually, this course is really useful also to me. I can implement my ideas in Python easily, but when you don't know what is happening in the background, you may find some bugs and you cannot handle that. But this was not the case for me when I was writing a C++ program. I knew what is happening in the background, so the number of times that I will encounter a bug was much lower than the number of times that I had a problem with Python. And when I want to be a professional programmer also in Python, and if you want to have such an interview in a company, they will ask about what is happening in the background. They do not need people who are only using the language. They want some people who are master in a writing program in that language. That's why I'm explaining everything in detail.
Yes. Okay, Miss.
Okay, so if you have any question, we can discuss. Otherwise, I should stop the lesson today.
I think no questions for me now. And if I have any